Hello and welcome everybody to the 3D BIM and 3D GIS Records webinar. Very excited today to be having this discussion and a fantastic lineup of panelists who you'll meet over the coming hour or so. I'd like to start off with a poll so we have an understanding of who's joining us today. Please indicate there so we'll all have an awareness of who's on. I think that'll help us shape answers to questions when we get to the Q&A. And per the notes, certainly would like to make sure that you remember we like this to be very interactive and encourage you to put questions in the Q&A area, and we'll endeavor to address those after the panelists had an opportunity to speak. I think this is an incredibly important topic because we're in the midst of a transition from paper and analog to a whole new era of doing things digitally. As I have experienced during my career doing this type of thing in the government, primarily in the defense and intelligence sectors, when things are in flux, when we find ourselves in a transition period like we have now, we often get people using common terms that are actually have them speaking past one another. And I think sometimes in this arena, we have producers and consumers using terms, but neither of them, in fact, have a common definition. And it is cause for confusion and frustration and mismatched expectations with respect to just what the technology can do. So it's webinars like this, when we have a broad participation from state, local, federal, from all types of other consumers across other economic verticals, as well as producers from myriad areas, that I think we can, in fact, begin to develop this common dialogue. So that we are speaking with one another and not at and past one another. Again, I think it's exciting today to have Marc, Matt, Nick, Cindy, Kyle, and Alec speaking with us. They bring a great deal of experience and understanding with respect to various aspects of this topic. And I think you'll find each of them have interesting things to say in their initial discussion. And again, hopefully questions will spur a vibrant discussion afterwards. So I'm hopeful we'll get the results of the poll here quickly and appreciate you indicating the poll information and data. And so here we have it posted, lots of participants from local government and then a smattering of others across. Great to see 100+ of you joining us today. Probably we'll have additional folks as we get over the next few minutes. So take a quick look at the poll, and then we'll be ready to move on to Marc. Why don't you go ahead with our first panel remarks? Thank you.
Thank you, Keith. Great to be here. Thank you, Bad Elf, for the opportunity to share my thoughts, Esri's perspective on this very important topic, 3D digital records. I'm going to emphasize how important location is as I go through a handful of topics. Keith, you really touched on some important things in that intro, how we tend to talk past each other when there isn't necessarily consistency in our understanding of definition and terms. So I'll try to be, minimally jargony and buzzwordy, but let's just get going here. As explained, I'm Marc Goldman. My role at Esri, I'm the director of AEC Industry Solutions, which puts me in a place to talk about GIS in the world of architecture, engineering, construction, environmental management. And as you probably know, those consulting firms, those service companies work with state and local government, work with private sector, work with utilities. So I tend to touch on a lot of different types of industries. I like to give credit where credit is due. I've been in this industry of the intersection of construction technology going on, I'm into 3 decades. That is not a picture of me. That is a picture of Ivan Sutherland from MIT working on a product called Sketchpad also I just learned yesterday called robot draftsman, which I love that term. Probably 1962, the first CAD application, Ivan, was a critical groundbreaker in the area of graphics and user interface. I got involved in the world of CAD actually quite a while before that application that just popped up. That was AutoCAD 2000. I got involved in AutoCAD in the late 80s, early 90s. Really didn't touch on GIS until rather recently. I worked at Autodesk twice, once in the days of AutoCAD and once in the era of Revit and many, many applications. And these days, my world involves the intersection of GIS and AEC technology, certainly involving BIM and scheduling content and project management and environmental management types of solutions. And that image that just popped up is an application called ArcGIS GeoBIM, which I think I'll show some applications of it later. A little bit here just before we jump into all the content. If you want to know how to reach me, hit that QR code, make a screenshot, take a picture. That'll take you to a real quick 5-question survey: name, company, email address, and I'll be able to get in touch with you. So as I mentioned, my world of AEC did not involve GIS until rather recently, and I think my understanding of what GIS was similar to most folks in the world of architecture, engineering, and construction. Sort of the built world was that GIS was a mapping application. It was a tool used to create typically a 2D map. But I've certainly come to learn at Esri and beyond Esri that GIS is much, much more than that. It's field operation applications running on mobile tools. It's the whole world of data science and spatial analytics, and certainly 3D is part of that as much as 2D. It's bringing in imagery and remote sensing type of content, which we saw just amazing examples last week at GeoWeek here in Denver. I know a few of the panelists and probably a few from the audience were there. It's being able to visualize real-time data through IoT and other sensors and other data collection. Maybe right time is better than real time. As I've said a few times, 3D. GIS is 3D these days, and the examples I'll show in a few minutes you'll see, are not your fathers or not your grandfather's GIS. They are compelling 3D capabilities, doing vast amounts of data management, and certainly in the case of Esri, with an amazing amount of and depth of and richness of developer APIs to turn maps into apps. So why do we talk about this? What is the sort of the context here? Why is GIS so important in the world of AEC? And kind of an obvious statement. AEC projects are spatial. Everything gets planned, built, designed, operated, maybe even eventually decommissioned somewhere. Location is a critical element of the way work takes place as we consider what to build. Where to build is perhaps more important than necessarily what. The impact on our communities, the impact on our ecology, the impact on the stakeholders who are going to consume or use or drive on or be enjoying the public spaces that get planned, designed, built, and operated are spatial. And AEC professionals, perhaps more than any other sector of professional, deal with massive amounts of data and many, many data types. And I would argue more than most any other industry, whether it's banking or medicine or rocket science, the types of data that professionals deal with in the process of getting something planned, drawings generated, submitted, reviewed, approved, feedback from various folks, eventually, construction managed and operated, just vast amounts of data. And location acts as an integrator, a connector, a least common denominator across the spreadsheets and CAD files and PDFs and field-based data and imagery and drone flights or satellite imagery, any of these types. That connector that brings it all together is location. And I've seen from almost my very first day at Esri, doing some demonstrations with Autodesk, how workflows where data is connected leads to people being connected. And when you connect people around their data and stop the workflows of simply throwing information over the fence and hope the person caught it and can do something with it, you really change the workflow and enable digital transformation. And digital transformation, I don't think anyone would argue, it simply is critical. It's critical for effective AEC project delivery. The way in which projects get delivered today is expected to be digital from the owner's point of view, all the way down to the person out in the field collecting data. No longer is a yellow pad with that information being re-entered, probably with errors, acceptable. Digital workflow from start to end across AEC projects is the standard. And we know, and we'll see examples in this next hour and plus, how important BIM is. BIM is that detailed level of information around the built assets, whether that asset is a bridge or a door opening. BIM remains critical for the AEC industry in the built world. And we're seeing more and more every day, quite honestly, the importance of GIS. It provides the context of the project. It provides location awareness, again, of that project, whether it's a bridge or simply a door opening of built and natural world projects of all size and type. At the world of Esri, we intersect with a lot of CAD, BIM, construction technology providers. We did some work with Autodesk to understand where and how GIS needed to be integrated into BIM products and BIM workflows. In a survey of some 300 or so respondents, 93% indicated that GIS integration into their BIM products and BIM workflows was important. Only 83%, though, a little bit fewer, said it was important to their daily work, still, a vast majority. But this is interesting, only 20% said it was easy, which is really a shame or an opportunity or a challenge, depending on how you look at it. So at Esri, through the lens of AEC, we focus on 4 aspects of the built world: architecture and urban design and planning, environmental consulting, engineering and consulting, and construction management. And we do that because we think there is vast amounts of time saving, construction, cost reduction, and many other benefits. And this data actually came from a survey we did with Autodesk through Geospatial World. These stats are specific to large projects, so I'm not going to say every project you work on, you're going to save a quarter of your time or 3 months, but projects that were significant in size and scale through respondents across the globe indicated that GIS, location data, context improved their projects. So in that world of architecture, urban design, GIS is this critical provider of context in the form of data that improves urban design, urban analysis, decision-making at a meta scale, and certainly visualization. This example is one that I received from our partners in Israel. Actually, if you're able to read the Hebrew on the right side there, let me know. This is a project in Tel Aviv where the BIM content got inserted into the GIS view to understand at various times of day, light studies, shadow studies, traffic patterns were analyzed. Once the project actually got built, the project then got scanned. So using drone flights to capture the conditions of the building itself, as well as existing conditions around through aerial imagery, helping the process of urban planning, urban design, context awareness, visualization, and various other levels of understanding were provided through this combination of 3D BIM and 3D GIS. In the realm of environmental consulting, GIS is a critical solution, critical data set, critical analysis tool to improve project efficiency, accuracy, to be able to make better decisions as it pertains to the biology, the ecology, and sustainability of our built world. This is an interesting project. It's now a couple years old. We actually, in the US, helped our Taiwanese partners schedule and plan a drone flight using some Esri technology. You can see the point cloud of this port environment pop up. You can see some BIM content on the pier itself, and then changing the sea level rise conditions from 1 meter to 5 meter to 10 meter, we can actually see what the architectural impact is. So building this building on top of the pier with enough, what is it, about 3.5 extra feet allows for sea level rise that's going to occur, we know, and yet this building does not get negatively impacted. Engineering and consulting in GIS, this is, in some ways, sort of the bread and butter of Esri over many years, using our tools to help provide geospatial context, different layers of data, traffic flow, weather patterns, the location of perhaps competition or partners that you might want to know about, the understanding of both above ground and below ground to improve the decision-making that engineering and consulting firms take on. Another interesting project, this is in Paris. I believe this was, gosh, I forget which firm this was. It'll come to me middle of the night. But they were tasked with defining and identifying the best location for additional metro stations in Paris based on the usage of existing transit. So in this case, it was a Revit file dropped into the Parisian fabric at the proper location based on where the population centers were and the use of the metro system existed. So this combination of 3D BIM and a 3D GIS, including demographics information and transit usage and population density, providing better answers to the engineers who needed to make the kind of decisions that engineers make. And finally, construction management. This is an area when I joined Esri, I thought was going to be sort of the sleeper of the project workflow. Why would you need GIS during construction management? But it turns out it's one of our hottest, most richest areas of customer value. When you combine GIS, which is all about location information and context, and not just the where, but often the when. GIS is very time-based. When you're able to combine GIS with cost, time, and safety, you're reducing the risks associated with those. And those are sort of the three pillars of construction management: saving time, saving costs, and creating safer environments. So I've got a few examples here that I love to show. This is HNTB replacing this old lift bridge in Norwalk, Connecticut. They brought in a combination of Revit and Bentley content into a GIS environment. You can see the lift station at the tops of this 80-year-old bridge, I believe, that's being replaced by a new cable stay bridge. And they wanted to make sure that this old equipment was not being negatively affected by pile driving happening right next door. So that little blue column you see on the lower left corner is the location of an IoT sensor. And as the pile driving is occurring, the environmental conditions, the seismic activity of the ground itself is being reported in this dashboard view, combining 3D and imagery and IoT sensors, helping the construction team know when to stop the pile driving because they are potentially creating risk of an old asset that still is critical. Another project, this comes from across the pond. Our friends at Skanska UK infrastructure team built out a mobile device using one of Esri's tools called Survey 123 that allows the construction and design teams to collaborate, understand existing conditions in the field. Every one of those little red markers in that map indicates a report that was generated showing where perhaps a safety issue existed or standing water or something underground that needed to be considered. They go out in the field, they collect the data, they come back in front of the computer in the office or virtually across multiple offices and review these construction design management hazards in this combination of 3D GIS above ground and below ground with field data collection. Another project from Skanska, also in the UK. This was an interesting project that, again, combined many forms of information. 3D in the form of BIM, 3D in the form of OpenStreetMap data, the actual tree locations placed on a 3D terrain, and then they used this application combined with other apps to understand the progress of construction. So again, their construction project management team would know the status of piles that were being drilled and eventually placed and then eventually QA'd in this dashboard-like view, rather than doing paper-based statusing or simply having a schedule that was always out of date. They had a real-time view of the status in a way that, anyone could understand this. You don't need to be a construction project manager capable of reading a work breakdown structure in a CPM-based schedule. This is just a simple dashboard. And one last one from Skanska, because I think this is really interesting. They bid on a project. They got all the drawings. They modeled them in BIM. They brought them into GIS, put together their proposal, and with about 3 weeks before final decision, they received another bid packet without a clear indication of what the changes were from the initial set of drawings and models to the next one. They brought it together in GIS, and what you should see pop up on the screen here is these two different overlapping views and these gantries located in new locations. So by means of using GIS and the location-centric approach, they were able to understand the changes between the initial bid packet and the one that they had to submit an estimate on in a matter of 3 weeks. These were point clouds and models and GIS and satellite imagery all brought together. And it's one of those success stories where GIS and BIM and all these tech brought together for bid stage that led to Skanska winning this project about 6 months ago, and I believe that they're moving forward with construction. So again, GIS for architecture and urban design provide these great capabilities we talked about. Environmental consulting helps save water, energy, and materials because of location. Around engineering, it's about decision making, improving the planning and engineering processes, and finally, construction management. So many benefits, not enough time to go into all of them right now. But if you do want to reach out to me, connect offline, or if you have a question, I've been keeping my eye on the question panel, but if you've got any questions, please throw them there. And at the end, we will be ready to answer them. And with that, at exactly 20 minutes and 5 seconds, I'm going to hand it over to Matthew Toro from ASU, who I know has got some great content as well. Thanks a bunch.
Good morning or afternoon or evening, wherever you're all attending from. My name is Matthew Toro, and I'm going to go ahead and load up my presentation here. And I'm hoping you all can see what I'm sharing on my screen and hopefully still hear me. I'm going to be talking about the Map and Geospatial Hub 3D Explorer. It's perhaps a far more modest example of some of the topics, some of the subject matter we're discussing today. And because it pertains to a micro scale mapping project for a small unit that I oversee at the Arizona State University Library. Right now, you're looking at the space that we occupy, including my office where I'm talking to you from right now, this office here in this corner. But yeah, so this is a digital twin, the first ever digital twin for libraries. Let's get right into it. So I'm going to transport you all virtually to Tempe, Arizona, a beautiful suburb of the Phoenix metropolitan region, where one of Arizona State University's multiple campuses is located. It's sort of the de facto main campus, Tempe, Arizona here. And this building over here to the right is a section of Hayden Library. And here's another shot of Hayden. So my unit that I oversee is called the Map and Geospatial Hub, as I just mentioned. And it's really just the traditional map library, as one would expect. We have tens of thousands of physical, analog, hard copy paper maps that we're actively digitizing. So one part traditional map library and another part modern GIS center. And this project here that we call the 3D Explorer really embodies sort of the epitome of that marriage between a traditional library map collection and a modern GIS center. This is what it looks like when you visit the Map and Geospatial Hub. This is sort of our the outside of our suite. We're located here on the 3rd floor of that building, Hayden Library, and this is how we've modeled it with a variety of tools. But I'll show you multiple views of our indoor model for our indoor suite, and obviously as we review and sort of tour more of this indoor space virtually, you'll note that the primary objects that we modeled are really very simple. They're really these three-dimensional, these rectangular prisms that are used to represent our flat file map cabinets, which, as I mentioned earlier, store tens of thousands of maps. We used to have approximately 150,000 maps, and partly because of the data that underpins this application, we have done some healthy weeding, as they say in the library world, or de-accessioning of maps. And we currently have about 80,000 physical cartographic resources, including physical historic aerial photos. So let me show, excuse me, didn't mean to click that. Yeah, that's a hyperlinked image. Sorry about that. So here, forgive the bad photography, my friends. My staff had bad lighting that day, but here's another view of that indoor suite. And here's how we've modeled it again in our Map and Geospatial Hub 3D Explorer application. So as you can see, we've really focused on a lot of the details. You know, we are an academic map library. So a lot of this sort of ambience of our room actually consists of map decor itself. So we wanted to ensure that we textured some of those simple map objects to really lend a sort of vicarious feel for what it's like visiting our actual space. Again, forgive the bad lighting. They chose to photograph on a bad day, but you get the gist of what this room actually feels like in the real world. And here's it represented in the 3D model. So forgive me, I should have had smooth GIFs. I hope this video loads. Live demos are risky, but live videos are also risky. Just wanted to zoom in. So we just flew into this Esri ArcGIS Online 3D map scene, and that showed the interior, or we sort of flew into the room. And I just wanted to give another representation of what this three-dimensional model looks like when you visit. This is a live web application that all of you can visit, and I hope you all do. And forgive me that I chopped up these videos into little multiple video sections. But let me tell you, what's the gist? What's the main purpose of this so-called digital twin? Well, first and foremost, it's a resource locator, which, as I'm sure many of you can imagine, even colleagues from the local government sector, just identifying assets and locating assets is, important work, right? Especially if you have large asset inventories to manage. And obviously in the library sector, that's sort of the essence of what we do here, right? So the beauty of this is that we have unparalleled locational specificity, right? We can locate the individual map items down to their individual drawer or shelf locations. You can also, of course, perform text searches, and obviously with sort of traditional GIS functionality, you can identify all the locations, and the app, when live, or when you visit it live, it will dynamically highlight all of the locations where the assets that meet your search criteria are located. And it'll also, if you want to sort of zoom in or identify one or more of those specific assets, like we're doing right now with this case, with this aerial photograph, it will show you exactly where it is, and of course provide metadata in the pop-up box. The main descriptive information about that asset that our users, which are really just library users, higher education library users, but also public library users, they can get that critical descriptive information about that asset in question. I'm pleased to report that our entire inventory, as I mentioned earlier, approximately 80,000 cartographic assets, have fully been uploaded, but I regret to report that we haven't digitized everything, right? So, libraries and institutions all over the world are facing this digital transformation challenge, but we are steadily making huge progress. But the goal, of course, is to have all assets fully digitized. So not only can you get the basic text-based descriptive information, but also, which is critical for our patron base, our user base, we want to be able to give people a quick view of what those cartographic assets look like, right? That's critical when you're just browsing for maps. Here's another quick video showing off some other functionality. So virtually everything in this three-dimensional model is selectable. So here I'm actually selecting the office location of the gentleman who did most of the mapping. Let me forward ahead here. For this 3D model. That's my colleague, Eric Friesenhahn, our map and GIS specialist. He did a phenomenal job modeling with both ArcGIS Pro and in SketchUp, this model. And here we're seeing a really fantastic plugin. It's called the Panelists plugin, and I'll talk more about the software architecture in a moment. But we added some open source functionality to really beef up the core functionality offered by the ArcGIS 3D web scene. Forgive the delay on loading this video. I might skip it if it doesn't play, but this video should be. I want to give it a chance to load. I will sheepishly move ahead if it doesn't load in a second. That is embarrassing. Forgive me, friends. But anyway, that video would have shown, oh, don't freeze entirely. That video would have shown the exterior view with the 360-degree panorama photo viewer, as we saw in the preceding slide. Let's talk about how this thing works. And I apologize for the cadence of my speech, my friends. There's so much to discuss here, but I'm cramming all of this into a quick 15-minute overview. But let's get into the nuts and bolts here. This is a quick Google Earth image. As you can tell, the imagery is a little algorithmically warped. But in any case, our Map and Geospatial Hub suite that I continually reference is located here on the third floor of this building. As I mentioned earlier, Hayden Library. It is really sort of the figurative and in many ways the geographical center of ASU's Tempe campus. So we're here in the northeast corner. And first and foremost, how do you get these assets, or how do you end at a live, dynamic, feature-rich web application? Well, you first have to assess or produce the data assets, and obviously in the BIM sector and construction management sector, those those documents are typically stored as CAD files, computer-aided drafting files, right? So the first sort of imperative, the first mandate is to convert those CAD data into a GIS data compatible format. And we did that. Eric Friesenhahn did a phenomenal job working with these CAD data, taking them into a 2D web map, and then of course through the magic of ArcGIS Pro, loading up a local 3D web scene, extruding those three-dimensional objects. We opted to go with the three-dimensional multi-patch feature object, which is a great way for storing these types of geometries. And we produced the basic sort of a skeleton, if you will, of the application. I realize I'm already running tight on time, so let's blast through and talk about the software architecture here. This is really the meat and potatoes of this application. So we're extremely proud that we employed a very simple and thus easy to maintain. With these customized applications, one of the biggest issues is the sustainability of the software. Often staff leave, you have one or two core developers, they move on, and then the rest of your team is wondering, how do you maintain this thing? And maybe they're poorly documented, but we're extremely pleased and proud of the fact that the whole application is fully transparent. All of our source code, I should mention, is available freely and sort of transparently on GitHub. We also use GitHub for our web hosting itself. So the application itself, and you can see the URL here and on some previous slides, the application itself lives on a GitHub page. And we're really proud of that. It allowed us to circumvent some of the bureaucracy and infrastructure needs of hosting with on-premise or cloud-based, or our own on-prem or cloud-based infrastructure. So here's the basic layout, my friends. We basically take a very simple database file. It could be a flat file, it could be a relational database, any sort of database file, but our inventory is relatively simple. Again, this is a relatively modest application of indoor space modeling and digital twinning, but we took that asset database, which has all of those descriptive metadata facets or descriptive bits of information about each of these cartographic materials or cartographic items. We link that to our 3D model geometries, and we did most of our modeling in ArcGIS Pro, but for the more sophisticated objects, which really aren't critical for the function, but they are critical for the aesthetics and really sort of the vicarious experience, the vicarious touring experience, and really simulating that environment with fidelity. We also use SketchUp for those models. So yeah, really just ArcGIS Pro. We were able to do the simple modeling, SketchUp the more sophisticated geometries, link that database file with the three-dimensional geometries. We're notwithstanding the use of Trimble SketchUp and Esri ArcGIS Pro and ArcGIS Online, we're really proud. So those are sort of the proprietary software components, but we're really proud that we invoke this sort of hybrid software stack that uses traditional web-based languages, HTML, JavaScript, cascading style sheets, etc. And with the power of various plugins, ArcGIS plugins, etc., and APIs. We're able to take this hybrid, this sort of partly free and open source, this FOSS proprietary or software stack, combined with a few proprietary software tools like the Trimble and the Esri tools, load it all up into GitHub. All of it's free and sort of available for you all to check it out. And then we have this live feature-rich application, which I hope you all check out at that URL right there. It's kind of a clunky URL because it is a GitHub URL, but it's mapgeoasu.github.io/3D Explorer, and you can see it right there. So what is it exactly? We boast and there is an issue indeed about standardizing language and vocabulary, and I've attended some rather high-level conferences on the whole notion of a digital twin, really, and I myself will admit that I'm a skeptic, right? It's really, what is a digital twin? It's really just a 3D model. But if we really give due diligence to this notion of digital twin, it's more, there really is a value add when you start integrating the processes, and have real-time updates. So what does our relatively modest digital twin do for us? As I mentioned, it's a resource locator, it's a metadata describer, it's an asset visualizer. As I mentioned earlier, we're increasingly digitizing these assets. We have approximately a relatively small number, but 10% of all of those 80,000 maps digitized, so people can quickly view them and assess them for their research needs, and a space tour guide, which I think is really critical. how do you take a traditional brick and mortar institution like a library and scale it up, especially with a highly innovative and quickly growing and globally impactful university like Arizona State? How do you scale up a room containing thousands of maps? Well, you put it online and you make that map into an interactive web map or interactive web mapping application. It also allows myself and our staff to manage these collections, right? And I hate to overstate it, but it's a rather cumbersome process to open up a drawer, go through those assets. Now with this digital twin, we can sort of preclude, we can skip that step of awkwardly opening the drawer, digging through hundreds of maps, etc. We can virtualize it right there on the screen. And because we are an academic institution, right? We are a library. We want people to engage with our resources and our materials. So, sort of, it might be an overstretch or an overstatement, but sort of gamifying this and giving users a virtual space to sort of tour, dare I say, is a form of engagement facilitation. I just want to give credit to the project team, two of whom have moved on to bigger and better things, but myself, Robert Cowling, who's a rock star, a software architect and lead developer, he really did the programming magic to put it all together. Eric Friesenhahn, he did our 3D modeling, and my close colleague, Jill Sherwood, who has also moved on to bigger and better things. She helped with development and metadata processing. If you have any questions, please reach out to us. Again, my name is Matthew Toro, and I've been talking about the map of Geospatial 3D Explorer, which I dare to say is the world's first ever library digital twin. I'm going to pass it over to my good friend and colleague, Dr. Nikolas Smilovsky, to take it from here. Thanks, everybody.
Thanks, Matt. I really appreciate that. Give me just 1 second. I'm going to share my screen. Hopefully this all works. Yeah. Okay. So hopefully you all can see my screen. I just want to start by saying thank you to everybody that's gone so far and for all the attendees that have come to the meeting. It's been absolutely fantastic. Thank you, Keith, Marc, and Matt. Okay, and so today I'm going to be talking about trustworthy twins, the power of precision. We've been talking about digital twins and BIM data and 3D GIS data. Let's wrap all that together. We'll talk a little bit about Bad Elf. But before we start, I want to run our second poll for the day. So there should be a poll that pops up on your screen any moment. There it is. Okay, and it's just a couple quick questions about geospatial solutions, if you wouldn't mind. One, we'd like to know if your organization is interested in implementing any type of geospatial solution, obviously, maybe specifically speaking to what we're chatting about today. We're also interested if you are looking for geospatial solutions, what kind of time frame are you looking? Is this something in the near term, something in the next few years? And then last but not least, we'd like to know where you're going to implement the geospatial solution. Is this something you're trying to tackle internally, externally, or simply you're not trying to implement, or maybe you already have all these geospatial solutions and you're beyond this. So if you wouldn't mind, go ahead, take a couple seconds here and answer that. While you all are answering, I'd like to go ahead and just talk about what we're going to be discussing specifically about Bad Elf solutions, and this digital twin thing. So I'm going to start by quickly reviewing in all of a few minutes the differences, kind of the pros and the cons about 3D data. I call it, are all 3D data built the same? We're also going to quickly look at Bad Elf, who we are, you've never heard of us, how we can potentially help you. The main crux of my presentation is actually going to be discussing anchoring the digital twin, the importance of using different types of geospatial technology to anchor or geo-reference data so that the actual proper location is being used. You saw in Marc's presentation earlier today that he kept saying location matters. This is very important, right? Especially in terms of three-dimensional data. We're going to talk about how can we get there? How can your organization start to embrace these types of new 3D data? And we're going to kind of wrap up with a promising future. So let's go ahead and take a look at the geospatial solutions poll, and we'll wrap that up and see if everybody is interested or not in doing this type of work. All right, there we go. So looks like right now we've got about half of the attendees that are interested in implementing geospatial solutions. So win, that's a great notion. If you're here, hopefully you're seeing the benefit and the power of GIS and BIM. The other 50%, you're not really quite sure. I think the best part of that first poll is under 10% of you think that you're not going to do it, aka computers scare me. So this is a good trend. Embracing novel technology. What kind of time frame? So it looks to me kind of a wide distribution, kind of a bell curve, but essentially sometime in the next, let's say 12 to 18 months. And then the vast majority of you are saying that you want to implement these solutions internally, which I am a huge proponent for, and we're going to talk a little bit more about that as we go. Okay, so let's jump into this. Who is Bad Elf? No, we do not sell skateboards. A lot of people see our name on a line item and they're like, I have no idea what they do. We've been around for about 14 years. We've been creating GPS receivers. And in fact, we created one of the first plug-in GPS receivers to the very first iPods and the very first iPhone. So before integrated GPS existed in smart devices, Bad Elf actually made some of those original connections. We empower GIS survey and different government professionals to collect high accuracy field data. We're going to keep talking about high accuracy, high fidelity data. We can connect these GPS devices to any phone, tablet, or laptop. We work with all the different operating systems, so we're extremely inclusive, iOS, Android, and Windows. The fact of the matter is we want to dance with everybody. This is a new paradigm shift where at the end of the day, we want you collecting data in the systems you want to collect data in. You've seen Marc mention something like Survey 123 or field maps in the Esri ecosystem to collect data. Later today, you're going to see a great presentation from Alec Pestov at VGIS, and we're going to talk a little bit about 3D data acquisition. Suffice to say, Bad Elf does all of those things. We're an industry leading expert. We like to help design, implement, and deploy your custom systems of record. You're going to hear a little bit later what GET is. This is a team that I run. We call it the Geospatial Enablement Team. This team is effectively set up to help foster you into this new digital twin world to take you from zero to hero. We have two main GPS lines of data collection. So these are our two pieces of hardware. They're both in the Bad Elf Flex family. You can go to the App Store, Play Store, and download our app for this. Or you can fire up a third-party app like I mentioned, VGIS or an Esri product to go collect these geospatial field data, right? So we live in the world of BYOD. You take one of these receivers, depending on the accuracy that you need, you're going to Bluetooth connect it to your phone or tablet, then you're going to fire up your app of choice, and you're going to go collect great geospatial data. So depending if you need something handheld and small and maybe sub-foot, you're going to go with Bad Elf Flex Mini. You need much higher accuracy data, something we call engineering or survey grade data, perhaps to set a point of beginning, something we're going to talk about, a POB, you may want the Bad Elf Flex. So moving into the topic of conversation, that was Bad Elf, and we'll if you ever have any questions, please reach out to us, and we'll be in touch after the webinar for sure. But I want to quickly talk about BIM versus 3D GIS data. Some people might say that they're at odds with each other, and I would say that they're actually more integrated than you could possibly imagine. Of course, BIM, building information modeling, and specifically refers to buildings, say on the left side, and then 3D GIS, sort of this geographic information system that incorporates both physical features, like what you see, the landforms and the water riparian areas. Also, as Marc mentioned earlier, there's a temporal component or time base, right? But there's also a people component. Now, fun fact, the image you see on the screen here was actually created by generative AI. I said, hey, generative AI, what's the difference between BIM and 3D? This is what it threw up for us. So, take it as you will. So this is something I call Smilovsky's super simple data hierarchy structure. This is the most basic thing from about 5th grade, science class. So at the base of the triangle, I want everybody to think tabular or big data. This could be tabular data from a CRM or some type of proprietary system at your company. It could be tabular data collected from, say, social media outlets or the collection of your geospatial data through your phone. But I want you to think big data sits at the bottom, right? And we hear that as a key term, but big data has a part to play. Next, you have two-dimensional geospatial data. So Matt Toro just did a great job explaining how he's got 80,000 plus maps that have great, flat two-dimensional data. This could be things like parcel information. This could be actual aerial imagery maps. This is the foundation of GIS, but the truth is the foundation of GIS, 2D GIS, is kind of a decade old. At this point, you really need to be thinking three-dimensional, right? So then you get into 3D geospatial data. This is where we're talking lots of drones and remote sensing technologies and Earth observation satellites and ground penetrating radar. And then kind of above that, you've got, sitting on top of all this three-dimensional and two-dimensional and tabular data, you've got three-dimensional building data. They all filter into each other. And I want to just show you that there's so much overlap. I want to stop thinking about three-dimensional data in terms of built infrastructure in the environment. We need to be thinking about it all together. They all help with representation, data richness, applications, different types of benefits in terms of collaboration, decision-making. You can see that they're actually integrated, right? So the building has to live somewhere. The building needs to live in the GIS world, right? So where geographically does that building live? Marc showed a really cool video of that building being in Israel, right? And you could see actually like solar orientation in terms of landscape architecture and architecture. How is the sun going to impact the building? Well, you can't determine those types of things unless you have a spatial awareness of this, right? So what is a digital twin? So if you talk about archetypal terms, I think the digital twin sits on top of BIM and 3D. It's literally a digital twin of our Earth. But it is very important to point out that the twin talks about 2D maps. We've talked about that. 3D visualizations or models. We talked about that. 4D, which is time. It's a temporal component. We've talked about that. But I'd like to add two more things. Cost, return on investment, 5D. So you have the object, you have the nut, you have the bolt, you have the location. What's its cost? What's its impact? This is where we're really getting into like why BIM is powerful, why 3D data is powerful, right? And then project lifecycle. So actually being able to plan a project is that sixth dimension, right? You talk about the Map of Geospatial Hub at Arizona State. It does all of these things. Now, maybe students aren't so worried about cost, but if you're talking about cost in terms of time, the BIM model is actually helping them find the records they need in short order. So I mentioned the whole purpose of this conversation today for Bad Elf is I want to stress the importance of anchoring the digital twin. Anchoring meaning I want to actually place this thing into the real world. Now, if you are a land surveyor or you are an engineer by trade, this concept called POB or point of a beginning might be more, you might have heard of this, right? So the POB, and you can see on the image here, this is just a survey plat. It's a very simple thing of a boundary survey, but the first point collected, perhaps set on a monument, becomes the point of beginning. It's like the cornerstone that the church is built on. It's the piece that every other part of it kind of connects into, and it raises the question that we need to have high accuracy data collection so that we can place these things like BIM data or 3D data correctly, right? So it's the starting point, Marc's initial location from which all land surveys and geospatial projects start from. It's the ground zero of measuring and defining boundaries. For Matt, the POB in some aspect was kind of that building parcel data, that CAD or the CAD data that he showed, right? It has historical significance, by the way. Point of beginnings have been happening for a long time. In fact, I've got an example here where the U.S. Public Land Survey, established in 1785, started a point that famously kind of set all of the mapping in order for the U.S. Well, fun fact, you can go back 2,000 years and go to the Roman Empire. And in fact, there was literally a pillar in Rome that was the point of beginning that all maps and all travel and all geodesy from Rome was actually calculated from. So all the, marking, documentation, this point is usually a monument. It's some type of, back in the day, it might've been a rock cairn. It could have been a fence post. Now it's usually a rebar stake, whatever the case may be. This is how the data are set up. Without it, your data can be off place, right? And the worst thing for three-dimensional data is it not being in the right location. We're going to look at that in a second. And I just want to say it's important for all boundaries, surveys, GIS data, BIM. It's the reference point for all subsequent measurements. If you start to understand the relationships of space and how things interact, if that initial calculation is off, the rest of your data are garbage, okay? You can literally mess up this very first point, this point of beginning, pun intended, and all data downstream can be influenced and impacted. I want to make sure everybody quickly understands there's two kind of terms when we talk about accuracy. There's absolute accuracy. That's how accurate you are to the actual location, the known location on the ground. where precision is more like how accurate are you within the data set? How repeatable is it? Is the measurement along the roadway actually the distance? And is that roadway actually in the right place? These are different but similar concepts. If you don't understand this, please ask questions. We can talk about it more in the panel because I'm running out of time, or follow up with me. We can talk about why accuracy and precision is important. When we think about Bad Elf, you may conceptually think of like a cul-de-sac in your neighborhood. When we start talking about a point of beginning, you're really in that 1 centimeter. You're at a very, very finite location that is only very specifically in one location. You want to build that data from there, right? In fact, the digital twin is so important that there are actually ASCE standards. So the American Society of Civil Engineering has several SUE standards, so subsurface utility engineering. We could talk about that later. We're going to have upcoming Connect Me webinars on more about SUE. Not A Boy Named Sue, that's a great Johnny Cash song, but this is actually underground utilities. If you do projects in the state of California, the state of Colorado, different municipalities across the United States or even the globe, they are requiring you to have high accuracy data models now. You can't just start putting things in the ground, right? This is a street cut in New York City. You think we're going to have less stuff in the ground? Absolutely not. And if you don't know where things are, unfortunately, this is what happens. This was in Royal Oaks, Michigan, and there was a fatal pipe strike. And so a contractor hit a pipe underground. This is a very kind of in-your-face, shocking example. But if we don't know where our data are, where our assets are, the utilities, even the maps, this is the type of thing that can happen. Now, this is a pretty crazy video. I wouldn't be showing this if there was a fatality here, but this is real. This gentleman does live, but he's using a post hole digger to put in post holes for a fence line going into his home. What you're going to see here in just a moment is without proper geospatial data, catastrophe can arise. It doesn't take much. Now, granted, he runs away, but I think the point is made. You must have a good point of beginning. Any type of data, base and rover, laser offset, drones, any types of these things, if it's Bad Elf related or not. Perhaps it's ground penetrating radar and you're looking for burial sites for Civil War monuments. And so you're actually creating penetrating stuff to see under the ground. If you're looking under the ground and you don't know where it is in relation to things on the ground, you're lost, right? So you've already missed the point. That's another pun intended, right? Or perhaps you're riding around and you need to, you need to know where these utilities are located because you're retrofitting stuff for the community. This is important. Perhaps you're actually laying out parking lot lines or other type of infrastructure for actual building information models, right? Again, this is tying the building into the ground. So how do we get there? And I mentioned earlier, Bad Elf's got this great geospatial enablement team. We have several people on staff to literally that you can leverage for your needs, right? So we can come alongside your organization beyond just providing hardware, but actually help with the support, the training, the implementation. And so we can help get you to where you need to go. We have different types of packages. We utilize different types of solutions, Esri being one of them, but we have a plethora of others. And so I just want to leave you with this kind of little joke here. But so the Bad Elf on the left is the real world, and the Bad Elf on the right is the digital Tron sort of pixelated image, right? So it's the digital twin. XYZ, the lat, the long, and the elevation marks that spot. If you put CRUD into the system spatially, CRUD will come out of the system. No one will use it, and your project will be lost. So you've always got to start with a good point of beginning. I don't care if it's with Bad Elf or some other geospatial device. Make sure you are starting your project off on the right foot. The digital twin begs you. So thank you so much. I ran a little bit long. I'm sorry. I got a little heated. I love this idea that you have to position these things so all the data are on the same playing field, right? And so if you have any further questions, please reach out to us at bad-elf.com. You can email us at get@badelf.com. And so I'm going to wrap mine up right now, and I'm going to introduce Cindy Baldwin. Cindy's the president of VDCO Tech, and she's going to give you a little bit more great information. So Cindy, why don't you take it away?
Perfect. Thank you so much. I am going to share my screen here as well, and we will get started. It wasn't, here we go. So perfect. You will be seeing my screen. I'm going to take it into presentation mode, and you should be seeing my screen now. I'm going to go through a quick 10-minute sprint. All of these things are great that all my colleagues just spoke about. I struggle as a real-world practitioner how to do it. And that's really where I'm going to talk to you about as it relates to the AEC industry. VDCO Tech, we are architects, engineers, contractors, BIM, VDC professionals. We bridge the gap between real-world practice, traditional conventional practice, and technologies. And we work across the entire supply chain for architects, engineers, and we do a lot of owner compliance work as well. This actually is a contract that is currently being held by Broward County. We won it 5 years ago, and we actually just won it a second time. These will list some of the services that we do. The interesting part about this, we're a small business enterprise, 100% female owned. We were the prime contract holder on this. And what's different is this isn't just project specific BIM. This is organizational BIM. We can help across the entire public works division. And we've had owners piggyback this in the past. And my work, as I've been in the industry for over 30 years, 30 plus, I am a licensed general contractor. And I'm going to talk to you a little bit about some of the committees that I serve on. And I'm going to focus on Building Smart USA. My website and company website and my email are there should you want to reach out and have any questions after the presentation. But regarding Building Smart USA, we're talking about open BIM standards, the how. I chair this group, and we have 5 work groups underneath of it. We have Digital Twin, BIM to GIS, IFC, Data, and Simulation. The BIM to GIS work group is being run by Posh Supraprami with CNS companies. David Alvarez with Esri is also a co-leader on this group, and they're looking at horizontal BIM to GIS as well as vertical BIM to GIS. So it's talking about going from CAD to Revit to IFC into GIS and looking at open standards. When we're looking at open standards, this is something that the committee is looking at, but it's also something that I've worked with owners. This is something we did back in 2015, taking a CAD to BIM to GIS crosswalk, actually being able to contract for it. You look at the IFC entity class, mapping it to the GIS feature class, what attributes, what elements, what data do you need, who's responsible for providing them, and then you ultimately can contract for it. As a practitioner, we deal with all different kinds of software. So when you ask us to do as an owner BIM to GIS, sure, we can do it. And an architect, a contractor across the chain will say that we can do it. Because really it's just another tool, it's another app, it's another plugin that we need to look at to see how we're going to get from point A to point B. And as architects, Marc said it, we think everything is spatial. We've been working in the spatial industry, location. Clash detection and coordination is really where the BIM meets the road, right? It's spatial coordination, clash detection. And this is something that we need to make sure that what was being modeled on the design side is what was being constructed in the field. The contractors are using this for coordination to save them money and change orders, and we're documenting this along the way. This is what it looks like in real world. As an owner compliance agent for Broward County on their digital deliverables, we take real world conditions, we overlay them with photogrammetry, with laser scans. We want to make sure we understand the level of accuracy. We actually specify USIBD's LOA as a standard in our contracts. We then tie it into schedule because we want to manage critical path, overlaying the model so that you can get that visualization. That's what we're used to doing as architects, engineers, and contractors. So now let's look, we talked a lot about where it should be located, but that's not intrinsic to us as design professionals. This is a project that VDCO Tech has been working on, the Superdome. You look at the survey point, you look at where it is in the map, very simple. It's in the right location. That's a win. But you look at our other projects, Broward County Convention Center should be, you see the survey coordinates there, near Fort Lauderdale, and it's actually closer to Cuba because there it sits out in the ocean. I wanted to see if this was typical of our projects. I started to look at some others. This is actually a school board project in the middle of the state of Florida. And again, you can see little dot at the very, very bottom is where it comes in when you try to coordinate them together. So I thought, okay, Florida's crazy. I get it. I'm a true Floridian. Is it happening in our projects across the United States? And it is. So I looked at San Diego, Liberty Station. Liberty Station should be right there with the marker is in San Diego, and it's not. And the reason for that is the origin points for architects is typically 0, 0, 0. That's the control point to make sure that as an architect, all of our subcontractors and consultants, all their drawings, our models are coming in and are aligning to us. We then, as architects, move forward to the contractor to make sure that the physical world can build what we have designed. That's what we know and understand of spatial coordination. That control point 000 is typical. I ran an architecture company for over 14 years. In doing so, a lot of times we didn't have the survey point right off the bat. We knew the size and location we could do. We start designing and design development. We know that those real world coordinates can be put later. Also, 000 simplified our math. So when you're looking at that X, Y, Z coordinate, why our models don't always align in that geospatial world is because we're using that 000 coordinate. That is reality of what it is. The accuracy that we're actually concerned about when we're in the design and construction phase and building your capital projects is making sure that what I model actually can be constructed. It's the contractor's responsibility to sit it on the site. The measurements and the verification and the accuracy in our models, our complex designs, we need to make sure that we're not designing something so incredibly with tight tolerances that it can't be built. And then we need to look at the environmental factors. Those factors could be, is it a hot climate, a cold climate? What's the expansion and the contraction of what's happening in the materials that we're selecting? Again, to make sure that what we're doing can be built. If you are an owner in a government agency like Broward County and you're looking to go to BIM to GIS, you have to procure for it. You need to look at where your BIM and your GIS use cases are, where they match. Then you define it by your geometry, by the data, your file formats, and then ultimately the documents that you need. That will help you then develop strategically what you need to do with your model progression schedules, your facility data specifications, and then who is responsible. The design team, the contractor, and then ultimately it ties in through your BIM uses and where they have crossover and who is responsible, and then contract for it. Your BIM GIS guidelines, your crosswalks, your file formats, and that BIM execution plan isn't just something that you say, it's actually how you can hold your design and construction teams accountable. You need to verify that what they've said they've actually done, and you can hold pay-apps is what we do with a lot of owners to make sure you're getting the final end result. The end result from an architect, engineer, and contractor is complete and accurate as-builts. We want critical systems that are modeled, geometry, data, files, you name it. And if you want it to go to GIS, you have to specify the location so that we can put it in properly so our models aren't coming out in the Atlantic or Pacific Ocean. When we're working with our owners, we want you to say, do you want to do it how it is today, traditionally? Do you want to look at open standards? How far in those open standards do you want to go? And do you want to look into artificial intelligence? Then you look at the methods of the data exchange that you're going to require, where the interoperability needs to lie, who needs to collaborate and how, and then what that technical experience is. We're in a labor shortage in our industry and not everybody has this experience. And you weigh the pros and the cons. And then you look at the challenges, whichever method you pick, to the benefits. So traditionally right now, if we're not citing our buildings at the beginning and using 000, somebody at the end needs to do that because it's not an easy button that then just goes into a GIS system. And there's a lot of things that are happening with artificial intelligence. You know, Marc and Esri, Autodesk, Trimble, Bentley, these guys are leading the field in applying artificial intelligence and language models and computer vision into their software and tools. But there's also a lot of little guys out there that are doing the same. And I encourage you to look into that and to stay aware of what's happening in the industry, because artificial intelligence is going to help us with our labor shortage and our lack of maybe technical experience and knowledge that we have in going from BIM to GIS. Because why all of a sudden now? Like, why are we looking at BIM to GIS with such a priority? We've been working in it for the past 15 years, but now all of a sudden there's urgency, and it's because everybody wants the digital twin, not just the hype, they want the reality. If you want the reality on that, you have to define spatial data, asset data, process data. If not, you're not procuring for it. And then look at your historical data and your workflow processes. Scott Yates, these images come from Wolpert. He actually chairs the data committee with Building Smart USA. And these are the things that we're currently looking and defining as a work group. The digital twin elements and the construction data sources. So it's who's going to supply it and how they're going to give it to you in what format. So in a digital twin, if you're looking for that 3D model, are you looking at a Revit model? Are you looking at a SketchUp model? Are you looking at maybe an IFC, which is an open data source for models that can be shared in multiple platforms? So this is something that needs to be done as part of your strategic planning. Because ultimately what we have right now, everybody's heard of that golden thread. You want that golden thread of data so you have seamless data. But unable to get it right now, it's frayed. We have all this project data at the end. And that's where our handover, and that's where you're requiring your architect and your contractor to get together to make sure that your models are accurate and they meet field installation within a certain tolerance. In Broward County, we have everything from 1/2 inch to 2 inches of tolerance levels. That's an approved upon tolerance. And then what systems is it going into? It's not just GIS, right? It could be your CMMS systems, your EAMs, and then how the Internet of Things, that's what's making the digital twin have the simulation that's bringing it back to inform your decision making. All of it right now, unfortunately, is siloed. If we want to have that protected golden thread, we need to look at developing asset registries in a common data environment. That starts with our standards. It starts with data governance, making sure that we're looking at information management as part of our procurement process. Because if you do that, you can move seamlessly into GIS, into your ERPs, and your project handover just becomes really the easy button at the end, because all of that information has been properly stored. So the opportunities we believe as a company and when working with our clients lies outside of that conventional practice. You have to understand where your origin points are. You have to understand how to contract for it, who's responsible, and that can change per client. But we encourage you to look at how you ultimately want to tie in your geospatial data with your BIM VDC processes. Look to see what you can get intrinsic that people are already doing and providing. Contract for that and base it off of a business ROI. And remember that it's continually evolving. So stay and watch what's happening with artificial intelligence, because some of those roadblocks and open standards are starting to be, those barriers are starting to be broken. Building Smart USA does a lot with working with Esri, Autodesk, and the Open Geospatial Consortium, and it's a really good resource. We actually have, if you go to buildingsmartusa.com, there's events coming up. One of them is free and open to the public, where we're going to be using a mural board and following the sun with some of our data initiatives as it relates to digital twins, and we encourage you to join. So with that being said, I'm going to turn it over quickly to Kyle Burns with SketchUp, and he will be taking over from here. So thank you.
Great. So hi, everyone, and thank you for joining. My name is Kyle Burns, and I'm a customer success manager here at SketchUp. And today I'm going to be talking about the importance of 3D modeling and visualization. There's been a lot of great sessions about the GIS aspects of it, but my background is in architecture. I've practiced for about 10 years, and I'm a little more concerned with how things look, the design of it, and the visualization aspect of it. And my role here at SketchUp is I support all of our government users, so local, state, and federal customers, wherever they're trying to use SketchUp in any way in their processes and their deliverables. I'm that customer resource to make sure you accomplish what you're intending. So why 3D? Why is this important? 3D modeling provides value in a variety of ways. It's not just about pretty pictures. It's about combining and interpreting this data so everyone can understand. We live in a 3D world, and it's more natural for us to interpret 3D data than to make assumptions and translate words or 2D schematics into something that's going to be physically built. The goal of 3D modeling is to provide a digital representation that is used as a tool to help your project succeed. 3D can do a lot for a project and can be used at any phase in the project. The most important outcomes are getting more value from your data that you worked hard to create and gather, to overall enrich your deliverables regardless of the scope and the scale, and ultimately to create successful projects that will get repeat clients, repeat customers. Really, so there's a lot of different advantages throughout the process, but ideally we're creating successful projects. That means we're engaging more with people that could be members of the public that are being affected by a new project, that could be those who are paying us to develop these great projects. The more successful our projects are and visually they can understand it, the better chance that we're going to continue to have success throughout additional projects. And this has been addressed a little bit in previous presentations so far, so I'll just add a little bit to it. But there's always this question of BIM. And many times when we think about 3D modeling, the term BIM gets thrown around a lot. And BIM, of course, stands for Building Information Modeling. And it's a highly collaborative process that allows architects, engineers, real estate developers, contractors, manufacturers, and other construction professionals, really anyone involved in the building, design, or ongoing maintenance of this project, to create and maintain a structure within one 3D model. It's important to note that BIM will have different meanings depending on the industry you're in. So how you treat BIM as an architect is different than how you're going to treat it as a real estate investor, or maybe someone who's working at this building to ensure the maintenance and operations of complex systems. But it's all about optimizing and maintaining the quality of the built environment. The better the 3D model we have, the better the collaboration we have, the more successful that building is going to be, built up to the standards that we decided were important. And it's going to be successful when it's actually built and people are engaging and entering into that building or driving on that highway using that bridge, anything in the physical built environment. And BIM gives collaborators better visibility and decision-making, which results in more sustainable and financially successful projects. So BIM has a lot of components. It is a complex and complicated system. But I really want to focus on the visualization aspect of it. This is that creative and exciting aspect of the process, ones that I'm a little more concerned as an architectural designer. And that's the design, the execution, and the operations and maintenance stages. So here we've got a few examples of what 3D could mean. And 3D visualization can complement your existing workflows at any stage in the project. We can better understand real-world processes and project constraints. In the first example, if we're building a new building downtown, when are we going to be closing streets? How are we getting materials onto the site? How long are each of these phases going to take? And it's a simple to digest model that allows us to totally understand what is going on. It helps us understand how new work can maybe affect adjacent spaces and assets. We can also use it to get excited about upcoming projects with the use of renderings. This is really good for parks or fundraising, public input, something that taxpayer dollars are coming, paying for. They want to make sure that their voice is heard. They want to make sure that they can engage in this new and exciting project. And renderings are a really, really good way of doing that. Everyone can understand it. It could be great as an internal guide that drives the development of our cities or manages the complex systems of our assets. So we have customers that have 3D environments to ensure that when new developments are coming, that they're not adversely affecting anything else. And it's not a very complicated model. It's a simple massing model, but really, really powerful and easy to understand, easy to create, and easy to maintain. And then you can get into that really intense level of BIM, which is every single pipe, every single bracket, everything that needs to combine together in these complex buildings that we've got here on the lower right. So as I'm sure many of you are aware, the built environment in the AEC industry has a lot of old ways of doing things, hand drafting, archival data sets, and a variety of different ways to capture, store, and share that data. It's often a challenge to combine all of this data into something that's actually useful. So having 10 data sets that only 10 people can work on, that have to be in 10 different pieces of software, leave a lot of room for misinterpretation and project complications. 3D modeling is often used as the connector of this data. And it may not always be the total solution, but the ease in understanding the imagery will lead to a better overall deliverable in the project. So obviously we've got a zoning sort of diagram here on the left that is currently being used by the city of Portland. There's a lot of detail in there, but seeing something on the right is a lot more exciting and a lot more engaging for myself to fully understand what's going on in a new development. And then of course, 3D is dynamic. It's much more engaging and it's appealing to the masses. You don't need to be an expert to understand what's going on in 3D. Successful projects are a result of streamlined collaboration with the project team and the client. The client needs to understand that the architect or the designer is actually listening to them and producing something that they've asked for. So in addition to that, technology has given us a lot in the ability to share the model in more interesting ways, like this animation of a complex city. Videos, the cloud, augmented and virtual reality offer endless possibilities on how we can approach and deliver and engage with customers or residents. And visualization is great because it can help interpret project parameters, zoning, building regulations, and more. All of this is part of that BIM workflow, that discovery sort of workflow. And translating rules and regulations into 3D can expedite the design review process and result in more streamlined projects, including neighboring buildings, recognizable landmarks, infrastructure, can help the public better understand the placement of new projects and how it's going to impact their experience in a city. You know, this example shows an existing asset that's going to be demolished, the allowable height of a new structure, then the simple massing of a proposed design to understand setbacks, and then a more detailed image of a proposed building, on including transparencies or materials. So it's really showing how that is going to work with the rules and regulations of the city and how they're going to interpret that into a successful and exciting project. 3D can also allow you to better understand critical analysis for your project. So understanding how a project is affecting your neighboring environments is super important for successful and vibrant developments. In my experience, I've worked a lot with civic buildings and city halls and taxpayer-funded projects, and it's really, really important that we're not building something with a negative impact. We don't want to build a new city hall next to a great park that holds the farmers market, only for that city hall to block the sun for half of the year. I live in Oregon. Our sun is critical. If you're blocking our sun and our warmth in those days where it's not raining, we're going to have a problem with that taxpayer-funded project. One of the great parts about 3D is that it allows you to engage with the public a lot more easily. Providing simple but powerful visualization is a great way to receive feedback from anyone in your community. So not everyone affected by a project is a spatial expert. They're not all architects, they're not all GIS specialists, but they have important questions, and those questions could help your project be more successful. Their opinion is just as valuable as anyone else's that will be using these assets or living next to them. We want to be stewards to the built environment, and transparency is a really big part of that. So simply just seeing two different alternatives for a really big development, especially if it's close to a residential area, allows a lot of valuable feedback to come in. And one of the better, technical advantages of 3D modeling is the ability to problem solve. Discovering issues before projects have broken ground can keep your project on budget and schedule on track. This is a lot more of that BIM aspect where we do have those specialists and those collaborators coming in, but the imagery that we produce can be really creative and really cool to understand. So exploding axonometric views, putting in site and vegetation, scale figures, all of that helps us much better understand the scale and the scope of project, and have some really important conversations about, if we got a little wiggle room over here, can we make a cooler feature over here? But all of this needs to be done in an easy to digest manner so we can ask the right questions. And it's also really good when we can get an understanding of an existing assets, especially in O&M, operations and maintenance. We're going to be doing a lot of upgrades. The goal is to have a building or a piece of infrastructure be built and not have to do a lot of work on it. But things change, quality changes. We want to provide upgrades as easy, as fast, and as cost effective as possible. And in this sort of example, if we've got a 3D point cloud scan of an existing asset that does need to have some sort of upgrade, we can quickly model something, put it into the space, and understand if this is going to work with just simple visual clash detection You don't need to have complex systems to understand that a new piece of machinery is going to blast through the ceiling of an old building that was never really designed to house something like this. And again, with that complex systems, and integrations, it's important to have this 3D asset be easily understood, and have it be one data set to actually provide value and continue to be engaging and be able to be updated. If we are delivering some sort of BIM deliverable, but those folks that are in a building or managing this don't have the specialization or the training to continue to upgrade those models are no longer useful anymore, and we're not going to upgrade them. Everything is sort of going to be lost, and it's sort of the equivalent of just having those big sheets of drawings from back in the day that are just in bankers' boxes or drawing drawers that aren't used anymore. We don't know when these upgrades have happened. So it's really important to continue to manage these 3D models because they are so complex. Simple things like adding furniture or lighting to, again, better understand how all of these things come together is really, really important. And I think this has been talked about a lot as well as, how are we combining all of this into that, kind of that golden thread, especially if it comes into geospatial data. We've got so many experts working on building our assets, and we want this to be connected into a larger model, maybe a GIS model in this case. But it's important for it to be, a rich and useful asset. BIM, digital twins, GIS, digital records, they all seek to accomplish this heavy lift. So here we see, an asset modeled with some additional detail and just transparency, scale figures, vegetation, even the lighting at a parking lot, and it allows us to much better understand the scale of this pretty simple building. Maybe it's in an office park, and 5 of them look pretty similar from a two-dimensional point of view. But adding all of this stuff together allows us to quickly interpret this, to ask the right questions, to continue to manage it, and also deliver it to anyone who has the ability to understand this. It's really taking the specialist need out of getting value from 3D visualizations. And I'll talk about this just really briefly as, what's coming next for visualization. And AI is coming. AI is here. But I don't think it's coming for our jobs. It's coming to help us produce better, more interesting data sets. So how we implement it into our existing workflows, that's sort of the fun part for everyone to understand and start to figure out, the solutions that are out there. But when it comes to a 3D visualization, part of it, especially for me from a design aspect or what could be, we can take a simple model. In this case, this is a SketchUp model, just a massing model, and then give it some sort of prompt and a style that we want to see something in. So I've got this model that started, and I simply type in, create a photoreal image of a modern high-rise in a vibrant urban environment, and I'm given 3 alternatives on how AI could possibly interpret this. And again, this is really good for those who aren't designers, but they want to get feedback. They've got these keywords that are maybe important to projects or a city or town's identity. And it's just really cool because this allows us to get 3 alternatives in about 10 seconds. Again, more people being engaged in 3D visualization and modeling is going to make for a more successful project overall. And with that, I just want to say thank you very much. And I'm going to hand it over to our next speaker, Alex Pestov with VGIS.
Hello and good afternoon, everybody. My name is Alec, and I am the founder and CEO of VGIS. I've been working with some of the great companies presented today for some time. VGIS is the company that closely associated with Esri and BedElf. So briefly about us, you may heard of us in the context of augmented and mixed reality. We've been working on building augmented and mixed reality for BIM and GIS for about 7 years now, establishing strong relationships with Esri, Autodesk, and several other great organizations. And we also have been recognized by multiple awards, including Esri Partner Award last year and Microsoft naming us as top 4 developers in the world in our category for 3 years in a row. What I'm going to present today is how we utilize the concept of digital twin, something similar to what Marc described at the beginning of the session, and augmented reality to complete workflows that are specific to locates, to data collection in the field, and AEC. So recently we developed this component to our augmented reality solution, which is VSite. VSite is conceptually similar to GeoBIM, although it serves different purpose, and enables you to see your job site almost in real time from the bird's eye view. And that VSite component, which is web-based, is designed to work together with our engineering-grade augmented reality that you can utilize from the ground level to see your construction site when you are on site. So going to the AR component first, because it's easier to understand and get it out of the way, then we can see how it works together with digital twin. Originally, it was designed specifically for utilities management. So Esri was our first integration, and in that space, we can draw data dynamically from your GIS database, which allows us to deal with things such as frequent GIS updates, because our system will update itself automatically. Also, it will generate the model that you see on the screen from the attributes in your Esri ArcGIS, so that you don't have to build a 3-dimensional model yourself. It also allows us to work with data sets of massive sizes that can cover entire countries. So on the GIS side, it's a very powerful solution. Later, though, we started dealing with more of AEC information. So subsurface utilities is one of the key components of the system right now, as we can take BIM models produced in Civil 3D or scene services and display it with high accuracy in the field as well. That helps you with planning, excavation, utility locates, and a variety of other tasks to streamline the workflows. As quite a bit of activities happened not just below the ground, but at the ground level. We brought also different surface models into the view. So in this example, we worked with a surface model that was scanned, and we compared it to the pink, which is design profile in augmented reality, and you can instantly see where you have to cut and fill. And finally, building on that concept of BIM and 3D, we can display data from scene services, building scene services, Autodesk Construction Cloud, and a few other repositories, as well as common software such as Revit, Navisworks, to display accurate, centimeter-level accurate information in the field, both for indoors and outdoors environment. Although buildings come to mind first, the probably most useful case amongst our customers are roads, railroads, and utilities. So this is an example of where augmented reality is used to review regrading and redesign of this particular road. Another great use of augmented reality is bringing reality capture into the view. Point clouds reality capture is really widespread right now, and we can take previous excavations and display them as 3D meshes with up to a centimeter level accuracy in the field, and that allows you to peel the layers of the ground even after the trench is filled, and see inside to see how a particular asset looked like in real life. To ensure accuracy of visualizations, we integrated our system with different high accuracy tools, including total stations and survey-grade receivers. We work closely with several companies, including BetElf. Additionally, we have a few other positioning methods. So if you're working indoors, we have solutions for that as well. Recently, we combined our system with a digital twin, web-based digital twin. And the digital twin is designed to take data that typically exist in a void, such as BIM information and Revit, and place it in geographic context for planning, safety briefings, and a variety of other tasks. Digital twin can also be used for personal planning or for just general understanding of the job site. So when you're sitting in a truck and the weather is not that great, you can understand what you need to do and where just on your tablet with digital twin. And then once you step out, you can peel off the layers from the ground and see through the ground to understand where utilities are. And of course, on the same tablet, you can switch to augmented reality to see everything in the ground level with centimeter level accuracy. An interesting observation is that most of our customers start using digital twin. Probably 9 times out of 10, they deploy digital twin first and use digital twin. However, the augmented reality component on the right has very specific use cases. In this example, on this screenshot, you can see that the pipe was installed approximately 3 feet to the left of where the model says it should be. And then augmented reality is ideal for identifying, documenting, and reporting such discrepancies. Issue tracking or task tracking is another great component and use of that combination of digital twin and augmented reality. Typically, when you track an issue, it gives you it explains what you need to do. In our case, it also links it to the location. So location is a big component of everything we discussed today. In our case, the issue or task is linked to location. So the system will take you to the exact location where the task needs to be performed. And when you switch to AR, on site, it will guide you to the exact location. Those yellow tags that you see hovering in the air, they will guide you to the exact location or where this issue or task needs to be done. We've been working on making sure that visuals is not just for consuming information, but it can also generate information and complete workflows through augmented reality. So for example, once you get to that issue location, you can take a couple of pictures by simply tapping on the screen in the application. And those images will show up in our digital twin instantly as oriented images. And the oriented image will not just show you the issue, in this case, misaligned manhole, but it will also preserve the angle of the screen when you took this picture so that you can clearly see where the issue occurs. The concept of oriented images is compliant with standards that Esri set, and we're building interfaces for several customers to make Esri a permanent storage of such information in Esri ArcGIS databases. Another huge component of the system is the ability to capture reality. So you can use just your iPhone or iPad with BetElf, for example, GNSS attached to it for accuracy, and the system will generate mesh in real time so that you can see what you're scanning in real time. Unlike photogrammetry processors that take hours for the mesh to be processed, you can see the results within seconds or minutes on your iPad as it's processed directly on the iPad locally. And once you're ready, you click on publish, and 30 seconds later, that scan will appear in the digital twin so that you can compare it to your GIS or BIM records, identify discrepancies, and get general information from the field to understand how this project is developing. And of course, any scan that you do with VGIS is available in AR later on so that you can use it as the reference as you move around the job site. It's a very efficient way of capturing information before and after. For example, in this case, we scanned the trench before it was filled and after, and now you can easily identify all the discrepancies and changes between two states of the trench. What owners operators greatly appreciate about that approach is that it gives you a very detailed archive of a project, be that a small, relatively small project such as water main replacement or something on a larger scale. You can monitor your job site almost in real time. You don't need a lot of equipment. You can use an iPad paired up with BetElf and get awareness about what's happening on site, which is appreciated by quite a few utilities. And also, you receive accurate records that you can use for subsequent projects later on. The final component that I want to present is data collection. Data collection and data acquisition is a very important part of the system. And we have AR-based data collection, which is comparable to survey grade, except it's much faster and easier to use. So quite a few companies right now using that as the main method of data collection for linear assets, especially that any data that you collect goes directly into your ArcGIS, can be done in real time or available through the backend, where you can review and validate the accuracy in digital twin almost immediately. And I would like to bring all the panelists online for the discussion.
So if I might, I'm going to share my screen real quick to answer or add on to some of the answers that have come up. And I might have to mute myself real quickly because I'm in the process of getting solar panels installed in my house and had no idea how loud it was going to be. But let me share my screen real quick if I can get some of those answers. There was a question about IGIF, Integrated Geospatial Infrastructure Foundations, I believe. If you capture your screen or type in this URL, which isn't too bad, this is just one video. We're pretty involved with the likes of World Geospatial Industry Council and other organizations, and have folks at the Esri team who are quite active with United Nations and other global initiatives using GIS to help deliver solutions. There was a question about learning. We have something called Esri Academy. This in particular, this MOOC we're rerunning. Last year, I think we had 17,000 people dial into this. It's a free learning and training program that lasts for, you can see, about 4 weeks, once a week, I believe, 8 hours or so of content that was just really well received. Here's the sort of main website of Esri Academy. And then finally, someone asked about reality capture. Again, just one website to go to. We've got a product called ArcGIS Reality, which just gives a lot of information about the intersection between GIS and reality capture, reality mapping, and Esri's solutions for that. So with that, I'll just show these real quickly again so you can capture the screen. And then I'm going to go on mute because these guys are loud here.
All right, Marc, I appreciate you jumping in and answering some of those questions right away. And I just want to say thanks again to all of our panelists today that have dedicated their time to, sharing some information. I do want to let everybody know that Alec had to hop off. Unfortunately, he had another engagement, but any question we can't answer, we can certainly circle back around for everyone. So the first question I'd like to ask for the group is about environmental factors that impact materials and construction. I'm assuming maybe towards more of the BIM side, but is anybody out there, maybe Cindy, with your experience, 30 years, architecture, materials, building, maybe you want to take a stab at what are kind of some of the critical environmental factors that these models can track?
Well, what we find is architects were specifying materials, right? So in the specifying the material, we don't always model to that level of detail. So a lot of times you've seen visualization aids today, like SketchUp and things, but that might not be how you're generating your CDs. So there's a gap. And where we find that a lot of people aren't modeling, Broward County, they require you to what is modeled, your 100% CDs have to be generated for the model. So there's no inconsistency between the CAD and the BIM. Those files are the same. In those models, you will actually see expansion joints. So metal, for instance, in the heat, we're in sunny South Florida, there's an expansion there. You have to have expansion joints. And in those models, you'll find it. In other models that we get that might be more visualization aids, there's no expansion joint. But depending on how many different materials need expansion joints throughout your project, if it's concrete, if it's something that was moisture, that you need to allow for moisture in movement in that material, you need to have multiple expansion joints. That could throw off a project. If you have a large project and you're off an inch and you're continually off an inch, we have found buildings that are off 6, 7 inches at the end. Then you get a change order from a contractor. So that's where the process break we find in the field is not modeling those expansion joints. As an owner, as a government agency, just require that what is modeled is actually exported as your actual documents. You can have some details that are specified, but that'll enable it so that you don't have those dimensional gaps.
That's a great answer. Marc, do you mind jumping in maybe from a GIS perspective? Maybe you could talk about some kind of the power of GIS and say data sets that would be out there like heat and temperature and wind, and how when you overlay, you know, environmental factors in a more macro scale, how that can say impact or correlate to a, say, a BIM model maybe.
Certainly, yeah. I mean, the BIM gives you, you know, lots of properties that help you understand how something is going to get assembled and perhaps its impact in its, you know, direct physical place. You know, what might be
You've
underground.
suddenly gone
But-
mute there.
Oh.
We just lost your audio.
Did you? How about now? Am I still here?
Nope,
Oh,
can't
no.
hear you.
We can hear him.
I can hear
We
you
can
just
hear
fine.
him.
Okay, okay, great. Okay, I'm going to keep talking then. But beyond just that, you know, the 5-foot perimeter around a building, like you said, weather patterns, wind patterns, traffic flow, lines of sight, prevailing winds, information from National Oceanic Atmospheric Agency, NOAA, or historical temperature conditions, you know.
Oh, wait,
for a
Marc,
particular place.
kitchen sink, where is that on the list? Kitchen sink?
Kitchen sink is there as
Okay,
well. All
okay.
the kitchen sink distributors that you might need to know about. Yeah, the vast amounts of data just are amazing. When I get a chance to show some of the data sets that we have, I'll throw another URL out. Living Atlas of the World, livingatlas.arcgis.com, which is hundreds, maybe thousands of layers of data and deep learning models. If you can dream it, we've probably got it as far as data. It's not Esri. We don't ourselves collect data. We tend to curate it from other sources. We've got like 3,000 partners, and a whole bunch of them are collecting data, and we curate it. So yeah, the ability to understand context from just about every lens you could imagine. You know, where are your competitors, or where are your partners? Where do you want your building to be? And how dense should your particular project be relative to the density of buildings or population or location of grocery stores or college educated people with pets? I mean, there's really just no end to the types of data that are available in a GIS view to help you understand how to place your project, where to place your project, whether or not a roadway should cut through town or whether it should go around the perimeter to keep a potentially at-risk community from being disrupted by being divided in half. Yeah, context is king, and I can't imagine being an architect, a planner, a designer these days and not having a GIS tool in my toolbox right next to the BIM CAD project management solution I'm using.
That's great. Before we jump off the idea of data real quick, I wanted to offer up Matthew, if you want to hop on. Do you have any perspective in terms, because you obviously curate a ton of data that effectively become GIS or geospatial data. Any thoughts on this environmental factor data?
Wow, you really put me on the spot there, Nick. I would say try to be as comprehensive with as many variables as possible. My work here at ASU Library specifically perhaps isn't the most relevant, but I would say, you know, all those maps, if I can invoke the sort of the map collection side of it, all those sort of graphical elements that are physically printed on physical analog maps are bits of data that need liberation, right? So by digitizing those maps, we can actually get historic snapshots, which are very relevant for site model analysis and looking as comprehensively as possible at the plethora of variables that any sort of GIS analyst or construction management professional would need to incorporate into their project. So yeah, I think. Thanks for the opportunity, Nick. You put me on the spot, but I think it's an opportunity to basically say, you know, all of the information, or all of the raw, seemingly non-data geometric objects and shapes and lines and colors and symbology printed on maps are indeed sort of latent geospatial data waiting for liberation through digitization, through subsequent georeferencing, and through vectorization. And if I can just say, you know, the prospect of AI or the current reality of AI is really expediting a lot of that sort of data liberation, you know, taking these formerly printed ink spots on maps and actually turning them into precise point of origin or point of beginning geospatial data that can be integrated into a more holistic 3D model or digital twin.
Absolutely agree. There's a Harvard professor, his name was Dr. Carl Steinitz, who wrote a book about geodesign, and really it dates back to like landscape architecture, people like Sir Ian McHarg, and this idea of land, you know, like a layer cake analysis, but all those data points come in and you can start stacking them up in the GIS and it kind of folds up into the BIM. So I think that's great. We are, running out of time, but I'm going to actually ask 2 more questions, and I promise I'll shut it down after that. But I want to tee one up for Kyle. Kyle, there is some questions out there about more on the infrastructure of the actual software. So in terms of SketchUp, maybe you could talk about scale of projects, processing power, macro projects versus micro projects, maybe, federal size projects down to a little park. Any thoughts in terms, from a SketchUp 3D model perspective, how software is sort of catering to these different size scales for projects?
Yeah, so, I mean, SketchUp, when it started, was for architectural design, but really its power in 3D visualization is it allows itself to be useful for any size project. So we have people who are actually cities that maintain their entire city in SketchUp because it's just a little easier to adjust geometry or model things or block things out. And then there are people who design the tiniest little products, handheld ergonomic products. So it's not necessarily meant for one workflow versus another. It's meant to complement any part of a project. That could be interior design of one building, that could be urban planning to do 5 different massing concepts, because it's meant to be quick, it's meant to be easy, it's meant to be inviting. It's not meant to model every single nut and bolt. That's going to happen later on. It's more about winning that project and getting everybody to bring in, their opinions, their feedback to better understand it. And you can ask a lot of really, really powerful questions earlier in the project that don't lead to very expensive change orders and RFIs. Once the concrete truck starts pouring your new streets and you realize that all of that has been designed incorrectly, or that dashed line, that's actually an underground utility, they're actually striping that road with a dashed line. Those are the things that sometimes these really complicated and really excellent, powerful engineering drawings, they can get constructed incorrectly. Not everybody who's building what is out there in the built world, has a master's degree in engineering and understands what all they can pour formwork and they can do stuff, incredible things. They know exactly what they're doing, but they're reading the drawings. So if you missed something on those drawings, BIM and AI, it can't auto find all of this stuff. You do need a great QA QC manager and things like that. But SketchUp can really be used at any stage in the project. And, it's a desktop modeler. We have it on iPad. You can share these models on your phone and go into an AR, VR environment. It's more of a graphics program. So if you need a good graphics card, but the web can run on a tablet. It really just depends on to what level you want to take it. If you want your whole city, you're going to have some better practices and things like that. Just like any project, if you're not deleting your CAD layers in AutoCAD and you hand it to someone else and they're used to a different sort of set of standards, it's all kind of going to be messy. So there's really best practices, but it is meant to be a 3D sketching tool. It's meant to be creative. It's meant to be, there's a lot of possibilities, but if there are like specific questions about that, SketchUp is the most used 3D modeling software in the world. There are hundreds, not thousands of assets out there. And we don't shy away from recommending people to look at what other users are doing, because we don't have standards. We're not making you do one way or another. So some cities are really, really successful with just massing and things, and other cities, they actually use it, in their zoning code or in their, neighborhood development guidelines, where this is what the words mean. Here's what the setbacks are. Here's a diagram, so you don't have to misinterpret stuff. So really the best point of advice is to do some research online, because what you may think SketchUp was like 10 or 15 years ago when Google owned us and we were just populating, Google Earth, has really come a long way in trying to get more people's eyes on the projects and a better understanding of the 3D world in general.
That's great. I teach SketchUp to all my students at Arizona
Awesome.
State as well. And having libraries out there where you can go grab, these different models and things.
Yeah.
And, GIS, ArcGIS Pro can, take a SketchUp model, so can Revit. It's such a ubiquitous data file format these days. So more questions are coming in, but we are running so late. So Cindy, I'm going to let you jump in. Can you give us a 30-second rundown on the United Nations GTIM quickly?
Just go to Building Smart International. They have a liaison partnership. So yes, we are familiar with it. I know Marc is familiar as well. He participates on those committees. And Building Smart International will have the information as it relates to the United Nations. There was also a question regarding funding in the infrastructure bills. I believe Marc might have answered that as well, but just for the group, yes, 100%. ASHTO, again, Building Smart USA, there's a roads and bridge initiative where they're requiring IFC, geospatial location, and a lot of those, you'll find a lot of grants and some funding that's available through that infrastructure bill. So be sure to check those out. Building Smart USA and Building Smart International are really good resources that'll map you to the other partnerships, and you can click on their links and find more information.
Okay, great. So last but not least, I wanted to open this up to kind of the panel to jump in anywhere you want. And I'm just going to read the question because it's a little in depth, but the comment says, I see a collision coming. The user of each tool will want his or her file types to be the center of gravity and will ask the other people's tool create compatible file types for import-export. Project suggestions and updates look hard to manage across team boundaries. I can't believe PDF and Excel files are all we have. You forgot PowerPoint. All right, I've seriously taken so many telecommunication models and drawings from a PowerPoint file, so that's even worse. That's not even a joke. I can't believe PDF and Excel files we have. Question, could you please tell us what you want to see for the future of collaboration between AEC and CAD and GIS tools? So anybody who wants to jump in, maybe Marc, you started texting it. You start, but just everybody only gets 60 seconds. 60 seconds.
Yeah,
right,
I started an answer there. I typed something out. There's so much going on right now between the worlds of Open BIM and GIS. I could go on for hours. Building Smart International, Building Smart US, the Open Geospatial Consortium, ISO, amongst other organizations, are working to create their own standards, but also taking into account the other organization standards. So the flow of information between BIM and GIS is so much better than it ever was, both at the proprietary level between, locked down applications, let's say, and open standards. It's really amazing time right now. And yeah, the days of PDFs and Excels as the means of describing a project, are maybe not ancient history, but quickly moving in that direction towards really open flow of information across, open applications and commercial applications.
I will add that the collision's already happened. You're in an ego-centric industry. If you don't think an architect has a big ego, go meet a contractor. I'm a contractor, so I can insult all of us, right? We all have big egos in this industry. So the collision already happened, as well as with all the software providers. So the open standards, before we had complete unstructured data. Now we're starting to have structured data, but each siloed group and organization has their own structured data or their own semantic data model. And we're all starting to talk and play together. With AI, you're not going to need all of that. It's a complete game changer because the language models and the algorithms can be written in such a way that it can decipher and analyze the information that's out there. So I think that's really the game changer. I think where computers and the internet changed my life, I went to school with typewriters. I think artificial intelligence is going to change all of that and make our data interoperable even when we didn't want it to be.
It's hard to follow any comments about AI. Matt, throwing you under the bus one more time. You're next.
AI is the future. It's here. It's not the future. It's right here, right now. The future is now. There were a couple comments or a couple questions that I just saw regarding the metaverse, and absolutely, we're definitely looking at augmented or extended reality, pumping it into Unity and sort of building taking that virtual scene that's a web-based three-dimensional browser or web-based 3D scene that lives or is accessible through a browser, but making that a more truly immersive augmented reality or virtual reality experience. And of course, artificial intelligence will expedite all of these initiatives.
Wonderful. Kyle, you want to take us home?
Regarding the AI or the project standard file type?
The floor is yours, my friend.
No, I think, with more and more people again moving from the sort of the old way of doing things, paper, that there's a lot of great software out there that's really working to be the connector that can import in a lot of different file types. But I think it's important to have a good understanding of what you want to accomplish with these things. Do you want to run analysis? Do you want to make changes in those? Or is it just a digital twin? You know, a lot of times digital twins, you're still going to need to make changes in some other piece of software, but how often are you making changes? Is this just more for everyone to understand what you have for budgeting purposes, for scheduling purposes, for those, you know, 2040 plans, things like that? You know, maybe, you know, there's so much out there. I just recommend everyone to research and give it a try. There's trials there, you know, ask questions. You know, there's a lot of exciting stuff coming in, and, you know, be more open to anything, like especially in the AI. It's not going to take all of our jobs, but we need to know how to use it and harness it and be prepared. Because if we're saving time, then that means that we can take more projects on, we can hire more people, we can move away from, hey, we used to do 3-story buildings, now we're doing 10-story buildings. We're really pushing the limits of everything, and you want to be on the forefront of it. So you know, change is welcome and inviting, and I think it's an exciting time in the technology industry.
All right, well, I think that's a wrap, everybody. I really want to say thank you again to our panelists. I want to say thank you to the Connect Me folks and everybody that came. So attendees, we wouldn't have events like this if you guys didn't show up. So thank you so much. And I just want to say, I think we have a great future ahead of us. We can embrace it. We can evangelize for it. Yes, change can be scary. But if we grab onto it, the data, these AI tools, I think it's a very exciting time, and the moment is upon us. So want to say thank you again, everybody. And just so you know that this whole session is being recorded, and it will be sent out, and it'll be on the website for viewing later. Thank you very, very much, and we'll talk to you later. Thanks, everybody.